Welcome to Unit 2. So Unit 2 is all about the atom. This first lesson is just going to be a basic introduction to the atom and really guiding you through how to maximize the information that is presented in lessons 2.01 and 2.02. So you're going to learn some basics about the atom, about some scientists who discovered things about the atom, and what I want you to be able to do is create a table with those different scientists, what they studied or how they ran their experiments, and what they were able to discover. And I especially want you to highlight or pay attention for the people who discovered the neutron, the electron, and the proton. So we've got our atom and our different parts of the atom. Three of these things are going to be labeled as proton, neutron, and electron. And then I'm going to see if you can figure out what the fourth one should be. But pause the video, see if you can figure out what should go on these lines as far as what we're describing. And just to help you, fuller is kind of referring to all of this. It's a really bad bracket, but everything in there, the green pluses and the blue circles. So, if you remember your protons, your neutrons, and your electrons pretty well, protons are positively charged, electrons are negatively charged, and neutrons are neutral. So these circles each represent one of those. So the negative circles, those are your electrons. The positive green circles are your protons. And then the blue circles without a plus or a minus, those have zero charge, or they're neutral, and they are called neutrons. All right. This fourth item on here is, the center of the atom, which contains your protons and your neutrons. That is called the nucleus. All right, so those are the ways that you would label these things. If you knew all of those off the bat, awesome. If not, I definitely recommend, writing a picture, drawing a picture of this in your notes. All right, and then just some other basic information that I want you to know about the the particles, the subatomic particles. All right, if you want to title this slide, you could say this is subatomic particles. That way you're familiar with that term referencing protons, neutrons, and electrons. All right, you've got your proton and your neutron in the nucleus. Outside the nucleus is your electron. Sometimes we also call where it is the electron cloud. All right. But you've got your proton with a +1 charge, neutron with 0 charge, electron with -1 charge. And we're going to talk about this in more detail next set of lessons, but your proton and your neutron have equal mass of 1 AMU, which is atomic mass unit. And then we associate the electron with having 0 mass. All right, they are so tiny in comparison to the proton and the neutron, their mass doesn't impact the overall mass of the actual atom. Then one last component I want you to be familiar with is your protons and your electrons are always an equal number. At least for a neutral atom. All right, so, and this means number, at least for those of us that are really old and, pre-Twitter and hashtags. All right, so just in case you weren't sure what I meant by that, that's the pound sign or the hashtag can also be referred to as number. So, what I want you to do is you need to go through and read lessons 2.01 and 2.02, the Explore section. All right, so you're going to read 2.01 and 2.02. Under Learn, you're going to see something called Explore. All right? It's going to look a lot like pages out of a textbook. And there's going to be a bunch of different scientists that get discussed. All right? So what I want you to do is write down the different scientists' names, what they used or studied, that sort of thing. If they did an experiment, what did the experiment look like? And then what is their contribution to the atomic model? All right, some of them may have discovered the proton or the electron. Other people might have just, given us some, like a law related to the atom to follow. But what's their major contribution to our understanding of the atom? So, just, examples of what you might end up seeing. All right, so say from lesson 2.01, this actually may be a different Explore page now because this is prior to the new curriculum, but I'm sure there'll be something very similar related to Democritus. All right, so we've got the concept of the atom goes back more than 2,000 years to the Greek philosopher Democritus. Like others of his time, Democritus wondered whether matter was continuous, meaning it could be cut or divided into infinitely small pieces, or whether at some tiny scale matter was made up of particles that could no longer be cut or divided. Democritus hypothesized that the existence of particles he called atomos, which in Greek means indivisible, but the early Greek philosophers did not have the technology to prove or disprove their theory of the atoms. With the coming of the Dark Ages, science was placed in the back burner in Western thought and for more than 1,000 years. So, the Democritus is a scientist that you want to be familiar with. He was the first guy that proposed the idea that there was an atom. All right? But he was only really able to think about it and hypothesize this. He didn't have the tools to run an experiment. Then other people you might read about, they're going to have more detailed experimental type procedures. All right, so like Rutherford had a gold foil experiment. And the reading sometimes makes this a little bit difficult to understand, but I really like this experiment. So he had some items that he used. All right, he's got an alpha particle emitter, which alpha particles are the nuclei of a helium atom. All right, so this alpha particle emitter shoots helium nuclei at a piece of gold foil. All right, and this thin sheet of gold foil is only a few atoms thick. All right, you can think of it like this. There's only a few rows of atoms there. And then he has this whole thing surrounded by this detecting screen. All right, and the job of that detecting screen is to record when helium nuclei hit it. All right, so we can keep track of where those helium nuclei end up. All right, so what Rutherford found was that most of the helium nuclei, all right, most of them just go straight through. All right, almost all of them. You can kind of, if you follow this beam here, you can see most of that line shows up straight through. All right, there are a few readings, very, very few, that get deflected greatly. All right, and a few more that show a little bit of deflection, or a little bit of like bouncing off of things. But the vast majority of the alpha particles just go straight through like there's nothing there. All right, so Rutherford found that most particles passed right through the gold foil. Very few were deflected, and even fewer were greatly deflected. So he was able to discover the nucleus. All right, so he discovered that the nucleus exists. It's very small. It's dense, all right, because it didn't break apart when these other ones deflected off of it. It deflects or bounces, the alpha particles bounced off, and that it was positively charged. All right, so I want you to create a table and make sure you get at least these scientists down. These are the really, really important ones. All right, so we've already talked about Democritus and Rutherford. All right, so Democritus didn't actually have an experiment. He was just kind of proposing ideas. But he's the guy who coined the term atom. All right, and then Rutherford had his gold foil experiment. He discovered the nucleus. All right, he also noted that it was positively charged. All right, so that gives us some information there. So focus in on, especially on Dalton, J.J. Thomson, and Millikan. And you know what? There's going to be others in there too, so don't be shy. Add some extra ones. But I know you are definitely going to see stuff about these guys in the quiz.